Hey class, unfortunately I can't be in class to teach you lesson 6.7. We're skipping lesson 6.6 in case you're wondering. Um, so hopefully this video is going to help you get through it. Let me share my screen so you can see what I'm looking at. It's spinning. Give me just a second here, folks. I don't know why it's taking so long. There we go. Okay. So we're going to look at um, a specific situation, which does come up every now and then. And that is if you have a right triangle. Okay. There we go. So if this angle is right, and you draw a perpendicular to the hypotenuse from the right angle, you divide the triangle into two other right triangles. Um, and those two right triangles will be similar to the original right triangle. So if my original right triangle, if this was 20 degrees, say, and this was 70 degrees, okay, looking at the big right triangle, these would have to add to 90 because this angle's 90 and they have to all add up to 180. All right, now looking at this right triangle, since I made this perpendicular to the hypotenuse, this is a right triangle as well. If that's 70, then this little angle up here would have to be 20. And then since this angle and this angle add to 90, this one would have to be 70 as well. So I've got this angle with 20, 70, 90 as its angles, this triangle with 20, 70, 90, and this triangle with 20, 70, 90. Now, as we work through this lesson, it'll be helpful to be able to refer to the three sides. The side opposite the right angle is the hypotenuse. And now, of course, 20 and 70 were just made up numbers, but it would work for any numbers that I chose that the three triangles would be similar. Um, so there would be the short leg, which will be opposite the smallest angle. Remember, we looked at that the sides, the shortest side would be opposite the smallest angle, the medium side opposite the median angle. All right, I'm going to call this leg the long leg. It'll be opposite the a larger angle, not the largest because the largest is 90, but the larger acute angle. Larger acute angle. Okay, so looking at this diagram again, I'm going to pick different numbers this time just to show you that it really doesn't matter. If I had picked that this was 30 degrees and that was 60 degrees, this angle would have to be 30 because in this triangle, all angles have to add up to 180. So that would have to be 30. And then since this is a right angle, if this is 30, this would have to be 60. Okay, so it's been kind of dissected. This triangle here is appearing over here. This triangle here is appearing here, and then we have the big triangle. And I'm going to copy the angle measures. That's right. That's right. That's 60, that's 30, and this was 60, and that was 30. Okay. So triangle, if I do the 30, 60, 90, triangle bad is similar to triangle C, B, D. I'm just going from 30 to 60 to 90. Same thing over here, 30 to 60 to 90. So that would be triangle CAB. All right. So the fact that these triangles are all similar allows me to find some missing sides using proportions. So, excuse me. Here, I'm looking for this side, okay? Now, in that side is in this smaller triangle here, and it's also in the big triangle. In the smaller triangle, if I'm just looking at this triangle, notice it's the hypotenuse. It's opposite the 90-degree angle. If I'm looking at this one, if I put my numbers on there again, 30, 60, 30, 60, and you don't have to, but just trying to make the point. In the big triangle, it's opposite the 30 degrees, so that would be the short leg. So I could set up a proportion where I'm going to do hypotenuse to short leg. Okay? Because X is both the hypotenuse of one triangle and a short leg of another. So looking at, again, this triangle, the hypotenuse is X. Okay, what is the hypotenuse of the big triangle that X is in? Well, 9 plus, it's this whole side, which is 9 plus 16, which is 25. Okay, what is the short leg of this triangle? It's opposite the smaller angle, so it'd be the 9. And then what is the short leg of this big triangle? It's opposite the smaller angle. It would be X. Hey, look, when I cross multiply, I have X squared equals 9 times 25. So X equals the square root of 9 times 25. Square root of 9 is 3, square root of 25 is 5. So I don't actually want to multiply those out because I can take the square root of each individually, and that makes it easier. So X is 15. All right. Looking at this next example, this side X, it's not in the big triangle, is it? It's in the small triangle and the medium triangle. In the small triangle, and again, if I make up numbers, like if this is 60, then that would have to be 30, and that would have to be 60, and that would have to be 30. Again, those aren't the actual values. I'm just using them as an example to help me think through what's the short leg and the long leg. Excuse me. So X is the long leg in this triangle, and X is opposite 30 degrees, so it's the short leg in this triangle. So here I want to do long leg to short leg. Okay. So in this triangle, again, X is the long leg, looking at the smallest triangle. The short leg of this little triangle, it's opposite the 30, is 36. Looking at this triangle, what is the long leg? Well, it'd be opposite the 60 degrees, so it's the 64. And then the short leg is X. So it equals 64 times X. Cross multiply of X squared equals 36 times 64. X equals the square root of 36 times 64. Notice those are both perfect squares, so I can just take the square root of each individually. All right, so notice in both cases, we ended up with X across from each other. And so when I cross multiplied, I ended up with an X squared. That's going to be basically happening all the time. And this is called the geometric mean of A and B. So, excuse me. There's going to be two rules that I'm going to be looking at essentially that you need to know. One is when what you have is the altitude of the original triangle. Okay, if you have that. And the other is the leg rule if we're interested in one of the legs of the original triangle. So these words, altitude and leg, refer to the original triangle. And I'm going to just kind of jump um, to the punchline, I guess. A squared will equal B times C. Give me 1 second, folks. Okay. So the altitude will be equal to the product of the two parts of the hypotenuse that the altitude divides the hypotenuse into. Over here, when I've got a leg M, it'll be equal to, M squared will be equal to the entire hypotenuse times the part of the hypotenuse that is next to that leg. So it'll work if I have a leg over here as well. Then it would be L squared would be equal to P times O. Okay, so this leg squared will be equal to the entire hypotenuse times the part of the hypotenuse adjacent to that leg. All right, so um, when it says set up a proportion, I am okay with you writing one of these equations, all right? You don't have to actually write it as a proportion. Write it as a geometric mean. So the side that I'm given nothing about the legs of the original triangle. I'm given the altitude of the original triangle. And the altitude rule is the altitude squared equals the product of the two parts of the hypotenuse. Looking at this example, notice I'm not given anything about the altitude. Here, I've got R, which is a leg of the original triangle. So R squared equals the entire hypotenuse, which is F, times the part of the hypotenuse adjacent to the leg. So V is this part adjacent to the leg. And here, again, nothing about the altitude of the original triangle. I'm given a leg of the original triangle is D. So the leg rule is that D squared equals the entire hypotenuse times the part of the hypotenuse adjacent to that leg. So adjacent to D, which is T. All right. And here, notice I'm given an altitude of the original triangle. So I'm going to use the altitude rule, which says the altitude squared is equal to the product of the two parts of the hypotenuse. So I'm not going to use M. That's there just to make sure you know what you need and what you don't need. H and A are the parts of the hypotenuse, and you multiply those together when you have the altitude rule. All right, so let's do some examples where we actually find values. And here, X, notice, is a leg of the original triangle. So I'm going to use the leg rule, which would be that X squared equals the entire hypotenuse times the part of the hypotenuse adjacent to X, which would be this. This part of the hypotenuse is adjacent to this leg. And again, 49 and 25 are perfect squares, so don't multiply them out. Just take the square root of each one. X equals 35. All right, here, X is the altitude. The altitude rule is that it's the altitude squared equals the product of the two parts of the hypotenuse. So X squared equals 16 times 20 equals the square root of 16 times 20. The square root of 16 is 4. I can go ahead and take that square root. Square root of 20 We're not done doing simplified radical form. 4 times 5 is 20. 4 is a perfect square. The square root of 4 is 2. I can multiply that 4 and 2 together. You should give your answers in simplified radical form. All right. Number 3. Again, nothing about the altitude, but something about a leg of the original triangle, 36. So 36 squared is equal to the entire hypotenuse, which is x, times the part of the hypotenuse next to the 36. So x is in a different position here. 36 squared is 1296 equals 16x. If I divide by 16, I get x equals 81. And that's my answer. All right, here I'm given the leg. So I'm going to use the leg rule. 18, the leg squared equals the part of the hypotenuse adjacent to the leg, which is 27, times the entire leg. Oh, the entire leg is x plus 27. Now, 18 times 18, this is 18 root 3 times 18 root 3. The 18 times 18 is 324. The root 3 times root 3 is 3. I'm going to go ahead and distribute that 27 plus 729. So 324 times 3, 972 equals 27x plus 729. 972 minus 729, 243 equals 27x. 243 divided by 27, my answer is 9. All right. Again, we're given the altitude. So I'm going to use the altitude rule, which is that 25 root 3 squared, the altitude squared, equals the two parts of the hypotenuse. Now, one part is 75. What's this part? Well, if the whole thing is x, and this part's 75, then this part is x minus 75. All right, so you got to pay attention to what you're being asked for. You might have to do a little adding or subtracting to get the side that you want. All right, 625 times 3, when I square that, equals 75x minus 75 times 75, 5625. 625 times 3, 1875 equals 75x minus 5625. So 1875 plus 5625 is 7500 equals 75x. Divide each side by 75. 100 equals x. Okay, and I think this is our last one. What am I going to use? Altitude rule or leg rule? The altitude is labeled. Neither of the legs are labeled. So I will be using the altitude rule, which is that the altitude squared, so 3w quantity squared, is equal to the product of the two parts of the hypotenuse. So that would be 9w squared equals 8w squared plus 6w. Subtract 8w squared. All right. Hopefully you remember from Algebra 1 that when you see a quadratic, you should get 0 on one side when you see that squared term. And then a little bit of factoring. and then W equals 0, or W minus 6 equals 0, which means W equals 6. 0 wouldn't make sense here, right? Because that would give me no height. So W equals 6 is my answer. All right, folks, that is the lesson. Let me know if you have questions, all right? And I will see you guys hopefully soon. Bye.